All right, so today for 5-4, we're going to solve by taking roots. It's going to be fun stuff. So we're still solving quadratic equations. We're just using a different method. It's called by taking roots today. We're going to simplify radicals, including those with some negative radicands, and we're going to solve some real-world applications involving quadratic equations. All right, so equations in the form of x squared minus c equals 0, okay, in which c is a perfect square. So we've kind of talked about these, like there's kind of a shortcut to them. We're going to be really focusing in on those today. Can be solved using factoring, which was the previous lesson, or by taking roots. The way we do this is we isolate, okay, we're going to isolate the squared expression. What's isolate mean? Get it by itself, okay, and then we're going to take the square root of each side, okay, of each side. So an example would be x squared minus 81 equals 0. 81 is a perfect square, okay, where c is the perfect square. So I've got two methods here to show you. The factoring method, all right, which is what we've done in previous lessons and isn't wrong. We saw that it was that shortcut, that it had subtraction, so we were able to say, oh, this is the same one as x plus 9 times the quantity x minus 9. And then we set them equal to 0, and we solved and got x equals negative 9 or x equals a positive 9. Okay, in taking the roots, instead of doing that, we isolate the squared expression. So we get the x squared by itself on one side and the 81 on the other side. We added. Then we solve it. So we take the square root, the absolute, so this is going to give us the square root of x squared is the absolute value of x, which is 9. So that means x, you don't always have to write this step, by the way, but I want you to understand. The square root of x is the absolute value of x because it's positive. Okay, so x can be a positive or a negative 9, just like it was right here. We just wrote it out in a different way. Yeah, taking the roots is a little bit quicker, and sometimes you will have to take the roots. But that's why this says, like, remember, the square root of x squared is actually the absolute value of x, which means it's going to be plus or minus x ultimately. Okay, we're going to get to that point where the answer is a positive or a negative x. Because a negative 2 times a negative 2 is a positive 4, just like 2 times 2 is a positive 4. Okay, all right. So then the square root property states if x squared equals k and k is greater than 0, then x equals a positive or negative square root of k. So whatever that is, it doesn't matter what the number is. We're going to practice that down here. This is going to be helpful to see. So radicals should always be simplified. Okay, what that means is we have no perfect power factors in the radicand and no radicals in the denominator. All right, so if we're going to simplify this is just to get us started in practicing with the radicals. The square root of 450. Calculator is not going to help you so well. Right, because it's going to give you a decimal. So this is, do you remember like doing the division by square, or like primes, division by primes? We kind of talked about, I think, at one point.
I've done it before, but I don't remember all the prime numbers, so it doesn't matter.
Okay, so we do want to, because all the prime numbers, you probably do know most of them.
Like
1, 3, 5, 7, and then it jumps to 11. But really, we're going to use the 1, 3, 5, 7 more than anything, I promise.
Yeah.
And 2. Don't forget 2. Anytime it's an even number, so we're going to divide this bad boy by 2 to start out.
1 doesn't work.
Yeah, 1 will never work. It's not prime. It's a special number. Okay, so 2 goes into 450, 225 times.
Couldn't we
Okay.
go ahead and don't we want to do it by the biggest ones first if we can? I think we could by 5 or something.
You could, but you don't have, I mean, like, that's totally up to you. If it's an even number, I always go with 2. Like,
Okay, so this one
that just helps it up. We could do 5,
So
So it's 45? Anybody confirm 45? I hadn't done the math yet. 4 and then, yeah, okay, 45. 45 divided by, we could do 5 again. We get 9, then 3, and we get 3. So this is a prime number up here, right? So we're done. Are we following so far? Okay, good. What did I do that for? Because when I want a square root of a number, there needs to be, for me to be able to pull them out, there needs to be 2 of them, or they need to be squared. So I could write this as, this is the same thing as 2 times 5 squared, 5 times 5, times 3 squared, because there were 2 3's. That means that I can take this one and pull it out, because the square root of 5 squared is 5, and this one and pull it out to simplify it. So this is going to be 5 times 3 times the square root of 2. And then 5 times 3 is 15. So this simplified is 15 times the square root of 2. Because you're done. You simplified it. Because you don't have any perfect powers. The 5 was a perfect power, and the 3 is a perfect power in the radicand. I can't have those in there.
But you still have to leave the 5, because you have to still leave the 5 and the 3 in there, because there's 2 of them.
But they're not under the radical sign. They're not in the radicand. They're outside of it.
But there's only one outside. There's 2 of those. Because you have to square, so there's 2 5's.
But you're taking the square root of all of those numbers.
Right, there's only one, because the square root of 5 squared. So this would be, let me show you some other ways to look at this. So we could look at this as 2 times 5 times 5 times 3 times 3. And because there's 2 of them, I can pull it out. Or we can look at it as, well, this is the same thing as 2 times 25 times 9. You don't know the square root of 2, but you do know the square root of 25 is 5. And you know the square root of 9 is 3. So that's why we can pull those out, and we have to leave the 2, but we can take those out. But 25 is the same thing as 5 times 5 or 5 squared. Okay, so that division by primes helps us tremendously to get to this point. So if we look at the next one, the difference here is this radical is over the whole thing, the 50 and the 3, the numerator and the denominator. So we need, that's the same thing.
Can't you just take the 3 out?
Well, you have to put you can separate the radical. Right? So instead of saying the square root of 50/3, we could say, well, it's the square root of 50 over the square root of 3. It's the same thing. 3 is a prime number, so we can't do division of primes by that. But we can simplify the 50 to start with.
So it's 2 and
Well, 50 goes to 25, and 25 is...
Okay.
No, it's
not
5.
5.
It's 2 and 5 squared.
Okay, so if we divide by 2, we're going to get 25. Good. And then we get 5 times 5. So we can pull the 5's out. So it'd be 5 times the square root of 2 over the square root of 3. Okay. The problem we're not done, though, is because we have no radicals in the denominator, and we currently do.
How is it 5 times the square root of 2? Where did you get the 2?
Because the 2 was still here. So that's a good question, because this was like the square root of 2 times 5 squared. So we were able to pull the 5 squared out, but we had to leave the 2 there.
I was just like, do you always put that 2 there?
Nope, not always. Just we have to in this one. So now the numerator simplified. What do we do with how do we get rid of that that square root of 3 in the denominator?
Multiply both sides by the square root of 3.
Yeah, we have to. Not both sides.
Like,
what do you mean? What do you mean? Okay, so now I've got 5. So I'm looking at this 5 times the square root of 2 over the square root of 3. Okay, the only way to get rid of that is to multiply it by 1. Just like when we had, say we had the number 1/3, but we needed to add it to 5/9, right? When we wanted to add these numbers together, we had to multiply by a number that was equal to 1 that would get us the denominator we needed. So we multiplied by 3/3, right? So we'd have 5/9 plus 1 times 3 is 3. 3 times 3 is 9. You with me? A similar concept we're using here, we're going to multiply this whole thing by the square root of 3 over the square root of 3. Because the square root of 3 times the square root of 3 equals
3 squared.
not 3 squared, just 3. Right, 3 times 3 is 3 squared.
Yeah.
So
I was gonna say that the square root of 3 times square root of 3 is the square root of 3 squared. That's what I was gonna say.
The square root of 3 squared. Oh, okay, okay.
Like,
Touche. So you had the square root of 3 squared in your mind.
yeah. So then.
Okay.
The next step
Which
would
is
be
3.
to-
Okay. I'm with you now. I'm with you. Okay. What do we think? You think that you don't like this? Is it it's the radicals?
I'm not sure what it is. Like, I don't know. It makes sense, but it doesn't make sense. And I don't.
Okay.
Basically, like, you know the process, but it doesn't make sense on how that would actually work.
Okay. So then I would say that we probably need to do some radical work, like simplifying. And because it's this, I mean, like this unit is, like this section is about this. Like if we're not confident and comfortable, I was trying to combine those two words, with using square roots, taking the roots is going to be quite challenging. Let me finish this numerator problem here though. So if we do this, 5 times the square root of 2 times the square root of 3, right? 5 is on the outside. The other two are both under the radical. So we could say, well, that's the same thing as 5 times the square root of 2 times 3. What's 2 times 3? 6. So 5 times the square root of 6 over 3. That is our reduced answer. Because 6 can't be reduced anymore. We don't have so we don't have any perfect powers, factors in the radicand, and we have no radicals in the denominator at this point. So 5 times the square root of 6 divided by 3 is the answer. So let's see. Let's go ahead and try the next one because it's also just, I believe. No, I skipped the next one. I say in the book, I think no, it goes, because see, this goes to an equation. It looks gross. Taking roots can be really beneficial, but it is, I mean, you do have to understand how to take the roots in order to do it. And so that's why I'm like, if we're struggling, maybe it's a time to pause and look at that. So let's try this one and we'll see, so you can kind of see maybe the big picture of where we're headed. So taking roots allows us to solve some quadratics that can't be solved by factoring integers, because there are some problems, like, you know, Brandon had asked, are there going to be some that we can't factor? And I was like, well, not really to start with. But there are some that you can't factor. And so the first factoring methods that we learned are ideal. But then the ones that you can't factor, you have to have a second tool, a different tool in your toolbox, right? Like sometimes you need an impact and other times you actually need a drill, right? Or you need a wrench instead. Like we have to have different tools in our toolbox. So this one, solving quadratics, is we can do by taking the roots. So we do the same thing. We isolate the squared expression on one side. So we're still doing that. We're applying that square root property. And then we're simplifying the radical. or which is what we were trying to do. When we're doing this, there's generally two terms. So a is worked out. We have 3x squared minus 100, two terms. And this c is a perfect square. All right, so for this first one, we added 100 to both sides to get 3x squared minus or equals 100. We want to isolate, okay, the squared expression, so we need to get rid of the 3. So we get rid of the 3, and then we have x squared equals 100 divided by 3. The reason we isolate the x squared is so that we can square root it. Okay, so when we find the square root of this, it equals the positive and the negative of 100, the square root of 100 thirds. Okay, the nice part is the square root of 100 is 10. Okay, I don't know why that didn't, okay, print off very well there. So it is 10 thirds, or 10 over the square root of 3, but we can't have that radical in the denominator. So what would we multiply by to get rid of the radical?
Square root of 3 over the square root of 3.
Yeah, we're just going to use that square root of 3 over the square root of 3. So that's going to give me a positive or a negative. What's 10 times the square root of 3? It's just 10 times the square root of 3. And what's the square root of 3 times the square root of 3?
It's just 3.
I was like, so we can think about it as it's the square root of 3 times 3, but since there's 2 of them, that means there's just 3. So now it's simplified. It's positive 10 times the square root of 3 divided by 3 and a negative 10 times the square root of 3 divided by 3. But if this is not something you did a lot of in algebra, I could understand the concern. Okay. So how about I pause here and let me print off a worksheet, just simplifying radicals, and we'll practice that skill, and then tomorrow we'll finish these and apply it. Does that work? Okay.